Okay, here we go in our third video for this one topic, the degenerate point surfacing. Here's our model that we finished our last video with, and as you can see, the surface fill over here in the design tree, you can see that the surface fill is doing its job. If we edit the surface fill, we can see that we've got it set up with these two constraint curves kind of guiding the surface to let it know which direction we want it to go and to keep it in check. And so everything's looking good. The one thing I just wanted to really kind of hammer home was this concept of using these construction surfaces here. And I'm going to click on them one by one, these surface extrudes. And in the last video I had them hidden, and you're going to have them hidden as well. So that's just one point I wanted to really make sure to get taken care of was you can always go in here and right click on these and hide these surfaces, and they will go away like that. There you go, hide. Okay, you can also name these things in your design tree, and you can also put them into a folder right within your design tree. So if you select multiple things and right click, you can go add to new folder, and then you can call this construction surfaces. Let's just actually write it all the way out. There we go. There we go. So now we've got all of our construction surfaces sitting inside of a nice folder. And so this is just a way of keeping our design tree organized so that when we hand our work over later to an engineer or another industrial designer on the team, we're going to have no problems with them understanding where we were at. Okay? And just like everything else, you can unfold these. The other points I wanted to make is just that now that we've created a surface that's working well on this surface fill, really our job's only just begun, because the next thing we have to do is get this surface to look the way that we want it to. All right, now if I go in here and I want to make any changes to this surface, I mean, we have to remember we're using SolidWorks here, and one of the benefits of using SolidWorks is that, you know, we have parametric design capability. What that means is that you know, we have the option to go back in here and to edit any part of this model that we want at any point. And the parameters of this surface are all sitting right under here inside of this surface fill. You can see that I just re-added that guide curve, okay? So one of the things that I was noticing after I finished the last video was that our highlight here is kind of wobbly. Like if we look at it right there, if we look at it with the zebra stripes on, you can see that there's this little kind of odd dip in the part. I don't really like that. And so I'm just going to go back to the drawing board, and I'm going to edit some of the construction curves that I used to build this thing until all of that goes away. All right. So I have to remember that a lot of the original curves that I used to build this model are underneath this these surface extrudes here. So I have to get them up and away like that. So I'm going to right click there, turn that on, look normal too, and I just want to kind of adjust this a little bit. Okay, I just want a little bit more soft of a shape. All right, there we go. And I want you to really pay attention to these highlights here and see how they adjust based on the surfaces that you create. Okay, there we go. So I'm going to turn on my real view graphics right now just to see how the light's falling on this thing. And I'm just going to go around and I'm just going to kind of edit some of these surfaces here by editing the curves. This sketch here looks like it's got a number of relations on it, maybe too many. 2 pierce commands down here and 2 over there, and you can see that the sketch is black as well, which means that it's fully defined. I'm actually just going to leave this sketch alone. There we go. Okay, cool. Very good. Now I'm still noticing a little bit of a divot inside of my surface, and that's okay. You know, what I'm thinking is maybe it could be an issue with some of the guide curves that are running through this surface. So I'm going to just jump back into my surface fill now, and I'm going to just start to adjust these a little bit. There we go. In fact, I might actually experiment with taking these constraint curves off of the model to see how that affects the shape. There we go. Take that one off. That kind of smoothed it out quite a bit. Let's take the other constraint curve off. There we go. Let's try one and not the other. Looks to me like the best bet for this model is going to be to have this one constraint curve running but not the other one. Let's test it with optimized surface on and see if that does anything. Okay, there we go. Let's test some of these things here with just tangency instead of curvature. That's looking really nice. Okay, let's approve that. There we go. That's what I was looking for. Okay, so in terms of this model, it seems like the best move for us was to have one constraint curve running right down the middle. This constraint curve didn't work out for us. And this is the essence of surface modeling, right? You want to set up the surfaces you want, and then you want to edit from there, okay? There's no right way to do this. You just have to have a very kind of creative, artistic viewpoint on the whole thing. What I can do is I can teach you how to fill in a three-pointed surface, and then from there it's up to you to finesse that surface to be what you want it to be. In this case, the way I wanted this surface to run was I wanted nice, clean curvature across the board here, and I didn't want to have any divots or ripples in the thing. And now that I've got that, I can move on to the next part. So I'm going to hide that surface there, hide this surface here, and I'm going to go back and I'm going to mirror it across the right plane. We'll do bodies to mirror, knit surfaces. There we go. We're going to knit that across right there. We see that highlight is moving perfectly just the way we want it to. And then we'll mirror this entire thing across the top plane. There we go. Looking very good. That's what we want right there. Let's go to the Evaluate tab, turn on our zebra stripes one more time to just take a look at our work. And this is really the absolute best we can get in SolidWorks as far as curvature continuity across a variety of mirrored surfaces. Look at this thing and tell me that's not what we've been looking for all along. So you can see how the process works, right? First you set up your curves correct. Then you set up construction surfaces that you can work off of. Then you set up your surface fills, and then you set up your guide curves, and then you try it out, and then you adjust, and then you would go back and you adjust and you adjust and you adjust, and eventually you can land in a scenario like this where, as you can see from our zebra stripes here, I'll turn them horizontal. They are perfectly smooth across that transition from one surface to the other. Okay, so this is it. Okay, next thing I'm going to do here is I'm just going to go and I'm going to grab my planar surface, and I'm just going to cap this end here. I can right click. Now look at what's going on here when I try to cap this. Since I have 4 different surfaces here in the mirror, I'm trying to cap it, it's only grabbing one. Okay, so I can right click on what I know is an open selection of flat surfaces. Okay, I can click them one by one, but really what I should be doing is I should probably knit these all together now that I've done my mirror. So let me go to knit surface, go to knit surface, grab all of these like that. I'm not going to try to form a solid here because I want to do it myself. So I'm just going to go OK, knit them into one surface. I can confirm I'm on one surface by going up to here. Let's see what I've got. Surface bodies. Perfect. There's my one surface. These other surface bodies are still in here. They're hidden right now. These are my construction surfaces. I'll leave those alone. All right. Now I can go to planar surface and, excuse me. Let me grab this edge here, and I want to go to select open loop. That's going to select all the horizontal surfaces of that edge right there. Approve that. That's going to cap the end. I'm going to knit that surface into the rest of the surfaces. And now I'm going to do a try to form solid. There we go. Prove that. Cut the model in half to double check that I've done right. Now, my section view tool is turned the wrong way if you ask me. You can go over here and you can flip the direction of the section view tool using these buttons up here. There we go. That looks a little bit better, and I have a perfectly solid model now. Alright, so I'm happy with that. Very good. Now that I have a solid model, I can jump back and I can go to any of the solid modeling tools that I know so well. Give this thing like a 2mm wall thickness. There we go. Take a preview and see how that looks. Maybe 2.5, maybe 3mm sounds better for the size of this thing. There we go. Hit enter, approve that, and now we are good to go. Fantastic. Okay, so that's going to be the end of this video here. Thanks a lot for watching, guys. You guys have spent a lot of time watching videos on this one topic. It's a very difficult surface to get, and now you know what's coming. So practice this a lot. Set up your own types of scenarios. If you don't practice, you'll get your chance to practice when we start our toothbrush design, which is going to be coming next week. Okay? All right, guys. Listen, thanks a lot, and I'll see you in the next video. All right.